All right. So what is due at the end of the day today? Homework. So I generally don't like to do this too much in advance. I don't know, feeling kind of nice. I think I'll move the due date for that homework assignment to the end of the day Wednesday. So you'll have a couple extra days to kind of work on that. I don't like to do that because I want you to start studying for the exam that is Friday, right? But you know, I kind of leave it up to you. If you think that don't want to, make sure you get it done today, that's fine. You don't technically have to do it till the end of the day Wednesday. Give some of you those, a little bit of extra time. Kind of busy schedules. I would still suggest I'm just trying to get it out of the way as soon as possible this week, so you can kind of transition to looking through those two kind of set of quiz problems, which are really like kind of practice problems for the exam. Just putting them out, not all kind of at the end, but kind of different points along the class. And then I'll mention something about that second set of quiz problems here in a second. Yeah.
So you said our exams on Friday.
Yep.
So do we don't have to come to class?
Well, it's in class. Yeah. So it's an in-class exam. We'll do it. It's not, I don't have it completely. Wednesday, I'll have like more of the specific details on it. It's going to be around 25 problems, mostly multiple choice, with like the last one being something that, maybe the last 3 or 4 problems is kind of like more short answer, where I'll give a little more partial credit. But anything that I would use for that short answer question could be turned into multiple choice and vice versa. So stuff that we'll be going through kind of in class, a lot of these practice kind of problems for the exam will be multiple choice, but I'll kind of set them up as though I could, how I would answer them even if I didn't have the 4 choices in front of me. Other questions about that? Like I said, I'll have a little more specifics about the exact number of questions on Wednesday, kind of finalizing, writing it up exactly how difficult and what I went on there based on what we've gotten through. But really this week is no new material, right? So we'll just be kind of reviewing things we've already talked about. I would highly suggest showing up to class Wednesday because I think seeing me work through these, but also being able to bring questions that you have to class that we can work on is really helpful. Yeah. Huh? So it's no notes for the exam. I will try to think. I don't think for this section we probably have any equations that you would need. If I do, I'll mention it on Wednesday. I might give like a small formula sheet if there's any formulas I potentially could need. But most of the formulas we have up to this point is more of things that are going to be given to you. Like, the formula for demand. I'm not going to ask you to come up with them. I'm going to just give you what that formula is. Yeah. Any other questions for me before we kind of get going here? Okay, so you'll see later this afternoon that due date on this homework will change. I've got in the files here these sample quiz problems. Kind of we have those 2 big batches and then kind of their answer keys. So I think today I'm going to work on that second group. So it's just some of the newer stuff. So hopefully it's a little bit more fresh in our memory. And then Wednesday we'll kind of go back and look at the stuff that was a long time ago. That way we make sure we're refreshing our memory on some of those older types of questions that we could be asked about. Okay. So one thing I'll point out here, and you'll see a Canvas announcement when I get done teaching my classes for the day. If we come down here, anything past, so 13, 14, 15, 16, and 17, kind of can get rid of those. I'll repost these as well this afternoon so that you don't have to look at those anymore. I was maybe a little bit zealous in how much I thought we'd get through for this first exam. So we'll kind of save that batch of questions and those topics for later. Okay? But everything else is kind of like fair game or some good review. Okay? So we'll start at the top here. And it kind of goes back to elasticity, and then we'll work through some more of the kind of like surplus stuff, finding equilibriums, and then Wednesday we'll go back to some of the older stuff that we've covered. So for this first one, assume that we've got a 15% increase in the price for gasoline, which causes a 10% increase in the quantity supplied. With this information, we can say that the price elasticity for the supply for gasoline is blank. So anytime we're looking at elasticity, there's technically other ones, but the only ones that we ever looked at in this class, so that doesn't matter if it's elasticity for demand, supply. We thought about cross-price elasticities. Every single time, what was in the numerator was how responsive is the quantity, right? Now, we looked at elasticity for demand, that was the percentage change in quantity demanded over the percentage change in price. We're thinking about elasticity of supply, that was percentage change in quantity supplied for percentage change in price, right? But even when we're looking at cross-price elasticity, that was percentage change in the quantity of good X divided by the percentage change in the price of good Y. And I think the other one that we had talked about was income elasticity. So once again, percentage change in quantity demanded divided by the percentage change in income. Right? So all of these, right, we're always thinking about how responsive is quantity. So that's one good way to remember, like, we did want formulas, the principle that we're looking at how responsive quantity changes are to all these other things, right? Changes in income, changes in the price of other goods, or changes in the price of that good itself. Okay? Well, here we don't even have to calculate the percentage changes, right? We talked about how we could do that. That was kind of looking at the change and then dividing it by the average of those two. Right? Here I've simplified down to, I'm giving you the percentage change. So if I want to find the percentage change in supply, right? I'm looking at elasticity of supply here. That's simply going to be, what is it, 15 in the price and 10% in quantity supply. So 10% over 15%. It's looking to be 0.666 repeated. I'm doing the math in my head correctly, right? 2/3. So we would say that the elasticity of supply here is what? Elastic, inelastic, or inelastic? Inelastic, right? Because the three ranges we had, no matter what type of elasticity we're looking at, we said if it's less than 1, that was inelastic, equal to 1, that was unit elastic, and then greater than 1, I don't know why sometimes I write my one here, right? Greater than 1, we said was elastic. So calculating elasticities from these percentage changes, right? We should hopefully shouldn't be too bad, especially when we're giving you what the percentage change is. And this gets a little bit more complicated if I ask you to calculate that percentage change. If something like that would be, let's assume that initially the price is $10. And at that price of $10, we'll say we can keep this with supply, but we'll say the quantity supplied was, I don't know, 20. Then after a change in price, I'll try to choose numbers that are easy for me here. The price went up to 20. Because we're dealing with supply, we know that they want to supply more at higher prices. So the quantity change would be if it goes up to 40. Eraser here. So we use that midpoint method. How can I find, like if I'm not just given, like in this problem, how can I find those percentage changes? Okay, so this might be a formula I'll give to you, but we should remember that when we're looking at a percentage change, we're always going to use the midpoint. So whatever we're looking at, we're going to find the change in that variable, price or quantity or income or price of another good, and then divide it by the average of those two values. So here, if we want the percentage change in quantity, we're going to look at the difference between those two quantities, so 40 minus 20. And then we're going to divide by the average. Right? So to get the average, we would just add those two together and divide by 2. So more generally, right, you kind of think about this as Q2 minus Q1, and then divide that by Q2 plus Q1 over 2. Just take that change and then divide it by the average of whatever two values we do. So this is what, 60 over 2, 30, 20 over 30 is what? So this is like a 66% change. doing the math in my head. I might not. Right. Any questions on this? Okay, well, I found my numerator, right? But I still need my percentage change in price, right? What drove this change in quantity? So the percentage change in price will set up exactly the same way. It's going to be this exact same equation, right? Just find the change and divide by the average. Just now we're looking at price. So here, my price went from what? 10 to 20. So the change was 20 minus 10, right? Increased by the 10 there. Then the average, well, 10 plus 20 divided by 2. Hopefully, we're just finding the average of two numbers, so I should just add them up and divide by 2. So there I've got what? 10 over 15. Actually, I think I say 66%, 66.66 repeated here, right? But this is a weird situation where my percentage change in price was exactly matched by my percent change in quantity supplied. So here I would say that elasticity of supply is what? Unit elastic. Anytime those percentage changes are exactly the same, when I divide one by the other, I'm just going to get an elasticity of 1. Right? Or, this price change, supply exactly responding with the exact same percentage change. Right? So we would say it's unit elastic, right? Kind of matching each other unit for unit. And we could do this with, quantity demanded as well. It would really work the same way, with the exception of what's going to be true about my elasticity for demand. Instead of positive, it's always going to be negative, right? That's what we said. We're going to kind of take the absolute value so that we can think about these different ranges the same no matter what elasticity is. So that was even more than you had to do for this problem. I'm just showing you, like, if I did give you just the numbers, how you would actually calculate percent changes as well. Okay. Any questions over anything there? No questions? We're perfectly okay with this? Okay. So, maybe I can scroll down here. Let's say we've got price elasticity of demand for leather jackets is currently 1.4. And which of the following will not lead to a lower price elasticity for the demand? We talked about a few things that would influence the elasticity for demand, right? So this kind of really goes back to what does an elasticity really tell us, right? It's how responsive, and especially for demand, how responsive quantity demand is to changes in price. Okay? So we think about which of these would not lead to a lower elasticity, so being less responsive. Right, we're going to try to find which one wouldn't. Right, so if I saw an increase in the price for leather jackets, right? So this one's a little tricky, right? But it said something about this range for elasticity. Does everybody have this kind of race this way? Does anyone need to look this up then? So, one thing we said about the demand curve, let's think about prices down here. So I got my demand curve. We said that there's going to be some point on this demand curve, right? There exists some price for which we can kind of think about we're unit elastic. It might not be one price, it might be like kind of a change in this range of prices, but for the sake of what we're going to be the concept, we're thinking about there's just this price, right? This cutoff where at this point in the demand curve, we're unit elastic. We then said for these prices above that, for these higher prices, this was going to be the elastic portion of our demand curve. And kind of the reasoning behind why is because, well, even small unit changes in quantity here, like going from 1 to 2, is a very large percent change, right? So here, any movement we see in quantity demanded from price changes will be really large percent changes, right? Well, if we see a really large percent change in quantity demanded, more likely than not, we're going to end up with a really, something above 1 of the elasticity measure that is elastic. We then said for prices below that unit elastic point, our demand curve was inelastic, right? Because now those same unit changes in quantity, well, quantity is now much higher, so there's smaller percentage changes. Right? So now we've got smaller percent changes in quantity demanded in our numerator, leads to elasticity is less than 1, and we've got inelastic force. So if we're currently at what? A price where we're 1.4, we know we're somewhere on the elastic portion, right? So if I then see a price increase, right, I'm actually becoming more elastic, right? I'm moving further away from that unit elastic point. And we're looking for things here that will not lead to a lower price elasticity. Okay, this one's actually leading to a higher price elasticity. So we've actually already identified. We can walk through the other ones. Okay? So a decrease in the price, a decrease in the number of available substitutes. If there's fewer substitutes out there, when I see a change in the price of that good, I now don't have as many things I can go buy instead. So now the same price change as I saw before, if I now have fewer substitutes, I can't be as responsive to that price change. Think about it this way. Maybe if we do the extreme, let's say I move through having not just fewer substitutes, but no substitutes, like maybe something like insulin, right? Well, now there's no substitutes. They can change the price all they want. I still have to buy the same amount. I can't be very responsive at all to price changes. So that's going to be one where if we see fewer substitutes, right, that's making it so that demand is less elastic. We can't be as responsive. Right? What about a decrease in the amount of time? If I have less time to make a purchase, and when it comes to time, I always think about airplanes, right? If I got to be somewhere tomorrow, and I got to be down in Florida tomorrow, I can't be very picky on the price. I can't be very responsive to whatever the price is on that flight to Florida because I have to be there. I don't have any time to kind of shop around and find a really good price. So when we see a decrease in the amount of time, I can't be as responsive, so we would say I'm more inelastic, right? So B and C, we're being more inelastic. A decrease in the proportion of an individual's income that is spent on this good. This is the idea where we're using examples like if the proportion of income I'm spending on something is relatively low, I don't really care. I could see huge percent changes in price and I'm probably going to buy the same amount. The idea here is things like packs of gum, right? Or to make the real extreme points. If it's a really low percent of your income, you're not going to be as responsive. So if the proportion of your income that you're spending on this good goes down, I'm not going to be as responsive or I'm going to be more inelastic. Right? So B, C, and D are kind of these three main components we talked about, things that are influencing the elasticity of demand. They're all giving us situations where a decrease in the proportion of income, decrease in the amount of time, and a decrease in the number of substitutes, all those will make you more inelastic, right? Less responsive to changes in price. So the only one that did not make us more inelastic would be moving to those higher prices, moving along the demand curve. As we go up the demand curve, elasticity is becoming higher and higher, right? Or our elasticity measure is growing, getting larger, or more responsive. Excuse me. Any questions on that? So I would say one thing that might be good to have be able to draw a picture of is something like this. And remembering that the elasticity for demand is just measuring the elasticity for wherever you're at on the demand curve. So in my earlier example, when I said like we were moving from a price of 10, 20, the elasticity, the elasticity measure that we had was just for this portion of the demand curve. We're moving from that price of 10 to 20, right? And I think when we came up with it, this is actually where we said it was unit elastic, right? So we actually were finding that unit elastic. But at any point, any portion of the demand curve will have a different elasticity measure. The highest elasticity measure is kind of starting at the top of the demand curve, going to your lowest elasticity measures where you're then getting into the inelastic ranges down here at the bottom of your demand. Questions on So being able to kind of picture that in your head would be good. Okay? We're going to stick with elasticities here. Okay. So let's say I've got good X and good Y, and I'm wanting to come up with a cross price elasticity. So once again, I kind of made this a little bit easier that I'm just giving you the percent changes, so we don't have to worry about this midpoint after all. When we're thinking about that cross price elasticity, we said, had it up here earlier, it was the percentage change in the quantity of good X and the percentage change in the price of good Y. So here, what's Y changing? Y is going up by 20%. And X is, wait, did I do this backwards?
Yeah.
Y is going up by 10%. And good X is going up by 20. Okay. So my cross price elasticity is +2. If it's +2, what is this telling me about these two goods? Are they substitutes or complements, and why? So if the price of good Y goes up, and as a response, I buy more of X.
Is that the price of good X increases?
Price of good X increases by. Oh, so I just flipped it. So we're looking at, okay. So here, we're looking at a percentage change, quantity of Y, the percentage change in the price of good X. Kind of apply, I mean, it doesn't really matter what we call good X and Y, right? I mean, it's just, you know, we're thinking about how responsive now the quantity of Y is to change into this substitute of good X. So I can plug them in here. So Y, so Y is what? Y is the 10%. So this is 10 and this is 20. All right, sorry. Thanks for pointing that out. So if you don't read it incorrectly, right, it looks something like this. Okay? So we still have a positive cross price elasticity. So now when the price of good X goes up, the amount that we're purchasing of Y is also increasing. It's the same idea before, this positive cross price. So that's telling us that these two goods are war. If as the price of X goes up, I buy more of Y. That's telling me these two goods are substitutes, right? X is becoming relatively more expensive, so I'm buying more of good Y. I'm substituting away from X to purchase more of Y. If this was negative, that would tell me that they are complements, right? Because then if the price of X is going up, and that means I actually use less of good Y, that means it must be that I'm using these two goods together so that the price to use both of them is now also low. That's the idea of like batteries and anything that uses batteries. If batteries become more expensive, whatever goods use batteries, people are going to buy less of, because the total price now, if you think of, is actually getting higher. The total price getting higher, I want to consume less, which would make this percent change negative. So a negative cross price elasticity told me that these two goods were complements. So the sign of our cross price elasticity tells us whether or not these are substitutes or complements. And same idea, even though I misread it, right? It's kind of a good point, because we should always have that change in quantity in that numerator. Every elasticity we're looking at, right? That change in quantity, the percent change in quantity is what's in our numerator. Right? Any questions on this one? What's the next one? So we've got, over the past decade, we've got a 15% increase in income, and for what? Private education, and the quantity demanded for private education income has increased, and the demand for private education has increased as well by 20%. We would say that these are what? A normal or inferior good, and that the demand is kind of elastic or inelastic to income or income changes. So the elasticity of income is either inelastic or elastic. So once again, what should be in our numerator? All these elasticities what's in our numerator is percent change in quantity. Now here, we've got elasticity of demand with respect to income. So I saw a 20% increase in 15 in income and 20. So you've got 20% positive and then a positive 15. So I think this is what, 1.33 repeated. So we would say for sure in terms of whether or not it's elastic or inelastic, if we've got these ranges, something above 1, this tells us that the income elasticity demand is elastic, right? It's greater than 1. So right away, even if we weren't sure about the normal inferior good thing, we should be able to cross off C and D right away once we calculate that elasticity. Any questions on that? Is that clear as to why we can cross those off? Right. Once we've identified that we have an elasticity measure greater than 1, we know that we're in the elastic range. Excuse me. Now it's just determining whether or not this is a normal or inferior good. So remember, these are positive changes. So when I saw an increase in income, I saw that people bought more of this private education. It's kind of weird to think about private education as a good, but you can actually break it down, right? The quantity consumed just looks more like enrollments, right? But it's still, people are consuming or purchasing with the economy. There's more people sending their kids to private schools. So if income goes up and we see the quantity of private education also go up, we would say that it is a, if I have more money, so I buy more of that good, it's a normal good. It's just how we would typically think about most goods. The inferior goods are kind of the weird ones, right? That are kind of counterintuitive, right? If I have more money and I actually buy less of something, that's what we said doesn't really make sense, but there are some goods like that. I use crappy beer and like ramen noodles as the example, right, of good and inferior goods. But here, if private education is my normal good, what do you think is probably a inferior good? It's close to that. Public education, right? When we see that income is higher, we tend to see that there are then fewer kids sent to public, which kind of makes sense, right? If we're seeing more kids sent to private education, where are they coming from? They're used to be in public education at least now. Which is, I use these examples, I try to use like real world examples, which is kind of the case that we see. We look at the actual data. Okay? So there we're what? We're elastic, and we said they are normal goods. Okay? Questions on that? And when I say question, anytime we're working through one, you're like, well, yeah, what if this changed? Or what if it said this? Like, feel free to ask those questions as well. We can kind of work through something that's similar. All right, so consider the market for coffee. Since everyone needs coffee, and it doesn't matter what the price is, demand for coffee is, we'll say, perfectly inelastic. Which of the following is true if it's perfectly inelastic? So personally, and hopefully I'll try to give you a couple ways to think about this, but I think that it's really good to always be able to draw a graph for most. Like some of the elasticity ones, we're not always going to be able to draw a graph out. But a lot of times if we can draw a graph of whatever this market is, whether or not we're thinking about demand or supply, it kind of helps. Right? So here we're thinking about we have perfectly inelastic demand. So we've got quantity, price. If something is perfectly inelastic, that's telling us that people are not responsive at all to price changes. So when the price changes, they're not responding at all, perfectly inelastic. So what would that look like graphically? Yeah, no, you're right. So when I'm thinking about if I see price changes here, 20 to 10, I'm perfectly inelastic. The quantity that I'm consuming is exactly the same. It doesn't matter where the price changes to. If it's perfectly inelastic, people are going to keep consuming the exact same amount. This was the idea of a perfectly inelastic demand. So I think that's probably one of the options, that it's vertical, right? So which of the following is true? Well, never mind, that's not. We've got up there that demand is horizontal, but if we know it's vertical, we can rule that one out right away. Right? So rule out D. demand has a slope equal to infinity. So we think about the slope here, right? Or think about the kind of change in the price of y divided by change in the price divided by the change in quantity. It doesn't matter what prices we're looking at, right? Kind of rise over run. So it doesn't matter what changes we see in the y-axis. We always know that it doesn't matter what quantity, so you can put a value to it. Let's say it was, I don't know, 50, right? You're always going to see that you're dividing that by 0. Quantity isn't changing, it's not moving. So this is where we said that gives us kind of this, anytime I'm dividing something by 0, it's kind of like this infinite slope. So I'm guessing that's one of the options, right? We have a slope equal to infinity. But the other two, if we thought about, do those make sense? So if we had a price elasticity equal to 1, right? That would mean that we're unit elastic. So unit elastic means we are responsible for price. That one doesn't make sense. We know what we're perfectly elastic. And the other one, demand has a price elasticity equal to 0. So there actually should be 2 correct answers here, right? So we've got a slope that's equal to infinity, but we also know that it's perfectly inelastic. That elasticity measure should be 0. We're not seeing any response at all to these price rises. So we want to think about why that's the case. It doesn't matter what value we see here for the percent change in price. If it's perfectly inelastic, the percent change in quantity is always going to be 0. So it could be 0 over 20, 0 over 100, doesn't matter. We know that if it's perfectly inelastic, we're always going to have that percent change in quantity be 0. So we'll end up with a price elasticity of 0. The slope of demand will be equal to infinity. And we'll have a perfectly kind of vertical demand curve, which is not told us here, right? We have demand that's horizontal, but knowing that it's going to be completely vertical, we could have ruled out horizontal. Right? Okay. So this one, I think I'll update the answer. Okay, so there are 2 correct answers here. Right? If we're thinking about the slope or the elasticity, like the elasticity is 0, but that would mean the slope is infinity. So what if I told you it was perfectly elastic, right? Well, then you know that even the smallest, the infinitely smallest changes in price, in fact, even if you went to no change in price, if it's perfectly elastic, you're going to see extreme changes in the quantity demanded. So even if the price kind of stays the same here, if it's perfectly elastic, you could see huge percent changes in quantity demand. Right? So there we would have, we're thinking about perfectly elastic demand, then we know we're looking at kind of this horizontal type demand. Where, for if it's perfectly elastic, what would the price elasticity of demand technically be? It's kind of a weird one. If a perfectly inelastic good has a price elasticity equal to 0, perfectly elastic would be infinite. Yep. Right. So even same idea. If we're looking at the elasticity measure, because we have that percent change in our denominator, well, now our percent change for a perfectly elastic good is always going to be 0. Then it doesn't matter what change we see in quantity, anything over 0 is going to be infinite. So kind of it flip-flops, right? For the perfectly elastic demand, elasticity becomes infinite, and our slope of this demand curve actually ends up being 0. So kind of flip-flops this. Right, a flat line, that means the slope is 0. Okay. Good questions. Yeah.
What would be like an example of that? Like
A perfectly elastic good. There's not a lot of good ones. So I'll tell you this. these are good thought experiments, and they're good to like understand understand the extremes, and like as we get closer to those extremes, the kind of wild, weird things that are going to start happening. But in practice, like I guess like a perfectly inelastic good, you might be able to come up with some. Like I always say, insulin is like as close as you can get, right? But to be completely honest, at some point, I mean, if it becomes too expensive, I might just stop taking my insulin, like, right? Like there is a price where I'm probably going to stop by. Like it's not that I want to, but there is I mean, if it's more, a price gets higher than the amount of money I have, like I'm gonna stop consuming it. So there's never really a perfectly inelastic. I mean, insulin and these medications you need to live, that's as close as we get. Perfectly elastic, we're probably about thinking about things where those other conditions are true, right? That there's a lot of substitutes, right? That you have a lot of time to make your decision to buy it, and that it doesn't make up hardly any of your income. So when we're thinking about perfectly elastic goods, things that like, even if you saw a huge percent, like no percent change in price, you might change the amount you buy. Probably something like a stick of gum, right? There's a bunch of different types in front of you. They're all, you know, roughly the same price. Maybe today you got so many substitutes, you just happen to grab a different brand, right? Because the market we're thinking about, maybe not necessarily just for gum, but like a specific brand, right? So that's about as close as you can get to perfectly kind of elastic, where if you saw the smallest percent change in price and you've got these options in front of you, like the 25 cents ticket. Okay, if one of them's 30 cents and one's 25, I mean, unless I have like a real flavor preference, I'm probably just going to take the one that's a little cheaper, right? So that would be kind of the idea of a perfectly elastic good. We don't ever actually see one in practice, right? But we do see goods like get close to this, right, on either end. Any other questions on these? This is good, like to think about these things. Okay, where are we at? All right. So we're getting a lot of elasticity stuff today, which is good. I think I'm going to go down to some tax stuff though, and there's a couple of these that I actually like. So, okay, start at 12 because I really want to make sure that, you know, I know I'm going to give you some examples, especially like we spent a lot more time than I necessarily planned on, but it was good about talking about like government regulation or governments getting involved in markets. So with 12, let's say we've got this supply and demand curve kind of presented to us, and we're thinking about what quantity does maximum total surplus occur. It should be a pretty easy one, right? If I have a market that's in equilibrium without any government intervention or regulation, that is where total surplus is maximized for that market. So if I just give you kind of a quick, easy supply and demand curve here, you know that the equilibrium quantity is at 10. That's where total surplus is going to be maximized, right? So if I gave you something like this, you know that total surplus is maximized at that quantity of 10. You also could calculate total surplus here. So if I'm thinking about what total surplus is, I'll even break it down into a couple parts here, although without equations, we can only do so much with this specific question. So we're going to start at 25 and 5 with my intercepts here. I know that the quantity is 10. So total surplus is going to be the sum of producer and consumer surplus. Now I don't have the price here so that I can calculate both of those independently, but if I did horizontal lines up here, this is going to represent my consumer surplus, right? The difference between how much consumers benefit from purchasing that good minus whatever their cost is, which is going to be just the equilibrium price of that good. I'll then kind of use these vertical lines down here. That's going to represent my producer surplus, how much they're selling the good for minus their costs. Right? Remember, supply curve kind of represents the marginal cost of producers. So total surplus is the sum of those two. Right? So what we're really looking for, we want total surplus, is the entire area of this rectangle. Right, I said rectangle. So this triangle, right? What's the height of that triangle? Right, I want 1/2 base times height. So 1/2, I guess we can do the base first, right? It goes from 0 to 10. So the base is 10. My height goes from 5 to 25, right? So find the difference between those two. 20 times 10, 200 times 1/2 will give us that total surplus of 100. So even though we didn't have equilibrium price here, I can still find total surplus. Now, if you want me to break this down into producer and consumer surplus, what's the other thing that I'm going to need? The value of equilibrium price. If I have that, I can then actually calculate consumer and producer surplus individually. Because let's say this equilibrium price, I don't know, let's say it's something like 15. Okay. If that's the value I have for the equilibrium price, what would consumer surplus be? Now I just got this upper triangle, right? See, now one way to think about it is like consumer surplus in all these models is going to be the triangle that's on top. Maybe it helps write that down, right? Consumer surplus is the triangle on top, producer surplus is the triangle on the bottom.
So it would be 150.
Yep, so I've got 1/2. Wait, no, what's it on that? It can't be 150. Right, because the base is going to go from 0 to 10. The height is going from 25 to 15. Oh, right, yeah. Probably forgot to multiply by 1/2 or something there. So I think we actually end up with 50 here. I'm doing the math in my head correctly. Which at this point, what do I know producer surplus has to be? Yeah, if I know that the total surplus is 100, consumer surplus is 50. Difference between those two in a market without any government regulations, right? We don't have any tax revenues, deadweight loss. I know that those two have to add up to total surplus, so it must be that producer surplus is also 100. But we could actually go through 1/2, base is the same, goes from 15 to 5, and we can prove ourselves we actually get the exact same producer surplus. And that doesn't have to be true, right? That definitely doesn't have to be true. Consumer and producer surplus can be different. Right? It just happens to be in these numbers that I chose here. I probably should have chosen a different price just to highlight that, but they could be different. Okay. Any questions on that one? I didn't use any colors there, so sometimes I know people are taking notes. I'll use colors. I also, anytime you color out there, like horizontal or vertical, so you don't have to the colors. Yeah.
So it would incur the quantity of 10 and then like the total surplus is 100, right? Like that would be the answers for that one.
Yep. Yeah. And I might have had, this one might have had some multiple choice examples, and then I deleted those problems I told you not to worry about. So there might be answers in the actual file. In fact, let's see. Oh no, I left this one open-ended. So I did leave this one open-ended. So this would be like a good example of maybe like a short answer, right? Where you actually have to show your work, right? You could use a drawing, or you could use the drawing there to kind of identify this is total surplus. Show me your math calculation. And that way, even if you made like a small mistake, right? Like you forgot to multiply it by 1/2, but you wrote out that you were going to, and you just forgot to, I'm not going to take off like hardly any points. Because I can see that like you were 9/10 of the way there. So I'm not going to take away like half the points because you almost had it correct. So that's why like, those last couple problems I'll use short answers on. I'll try, I do that so that I can see that you were really, really close, so that you can kind of still get some partial credit there.
For a question like this, though, isn't maximum total surplus always going to just be with equilibrium?
Yeah, it would be an easy one, right? In the sense that it only becomes more difficult if I complicate it by throwing something in there like taxes. So if I had a situation like this, similar idea, but now it's okay, they've taxed this good, right? Well, now what quantity would surplus be maximized at? So surplus is always maximized at the equilibrium quantity that would exist without government intervention. Right? So here, I would basically just use, I didn't label this here, but this is my demand curve, right? It would basically be where the demand and supply curve intersect, right? Where our equilibrium would be if we didn't have the government regulation here of taxes. So if I look at that quantity of 8, now I can calculate total surplus by the area of the triangle, just like we did in the previous one, right? So almost like if you have additional things going on, excuse me, the way you can identify total surplus is just act like you didn't have that price ceiling, you didn't have that subsidy, you didn't have that tax, right? If you didn't have those, what would the equilibrium quantity be? And then identify where your total surplus is based off that. And a couple more things with this, we'll probably pick up a little bit, I'll finish this up on Wednesday. But let's say we have this tax, right? I didn't actually give you the value of this tax. Okay? But you've got your old supply curve, you've got the demand curve, you have your new supply curve that includes the tax. So what's the new kind of price that consumers are going to pay after this tax? I think you said it. 500, right? So the price that consumers pay will be where this new supply curve intersects our demand curve. So the new supply curve that includes the tax intersects our demand curve up here. Okay? So this is the price that we're going to see on the market that consumers are going to pay. But how much do the sellers get to keep? Well, there's a tax on this, so they get the $500, but then they have to pay out whatever the value of the tax is. So they'll get this amount minus the tax. Right? So the price that the sellers or the money the sellers or producers are getting to keep is only $300. And the reason why you know that you could go down to the supply curve here and find that is because the difference between that supply curve plus the tax and the supply curve is just the value of the tax, right? So I've identified that price for you, right? You can plug the quantity in and find, I'm not going to make you do that in the exam. But once you know that this is the price consumers are going to pay, you go down here to the supply curve, and you say, okay, this is how much the sellers are going to keep. What would the value of the tax be here then? Just $200, right? The difference between that. Whatever you and I pay, the amount that the producers keep is that amount minus the tax they have to pay to the government. Right? So if you've identified the kind of point you're at on the same quantity, on the supply curve and supply curve plus the tax, well, the difference between those 2 points is just the value of the tax. Right? So we've identified the value of the tax here without actually being told that it was a $200 tax. Right? What would total government revenue be here? So the new quantity that's going to be purchased or supplied and purchased on the market is going to be what? So the new quantity would be 6. How much is the value of the tax? We said it was 200. So 6 units are provided to the market and purchased. And each unit is taxed by $200, just 200 times 6, right? Or what? Well, yeah, 1,200, right? $200. So you just take the new equilibrium quantity, right? The number of units we now see in the market, multiply it by the value of the tax, which was just the difference between these price consumers pay and how much, price the consumers pay and how much the producers keep, which is kind of represented by this rectangle right here. So it's just the value of the tax multiplied by the quantity of units that are on the market, which kind of intuitively makes sense. Right? How much tax revenue is generated? Well, however many units are sold multiplied by how much we tax each unit. So we'll do a little bit more of the surplus with this graph, and we kind of go over some subsidy stuff on Wednesday. We'll then kind of go back to that first set of quiz problems. We'll look at some old ones. What I would suggest is that for Wednesday, right, if you have looked over that first set of quiz problems at any point, if you had any specific questions, like you could ask me and I could start with those, right? Because the whole point of me going over this is like to get us prepared for Friday. So I don't want to waste time if hopefully today, some of the stuff I worked, you're just sitting there thinking, I already know this stuff. I don't really care. We're going to ask, hopefully on Wednesday, you can ask me the problem that you actually do have some questions on. Okay. So, one more thing before you leave, I want to mention, I will be in my office a little bit later for office hours today, so a little bit closer to 3, but I'll be there kind of almost until 4. So it's kind of shifting my office hours up about 25, 30 minutes today. I'll be there from a little bit before 3 to a little bit before 4. Also, if you want to meet, have questions as you're studying, if my office hours don't work for you the rest of this week, feel free to reach out, email me, and kind of set up a time. Other than that, good luck studying, good luck kind of finishing that homework, and I will see you guys on Wednesday.
I have a question.
Yeah.